All right, now for problem number 27, it says that we have an ideal transformer that steps 8 volts up to 2,000 volts, and a 4,000 turn secondary coil carries a current of 2 amps. It doesn't say current, but that's what that is. And it says find the number of turns of the primary coil. All right, so they give us the secondary coil. They give us the voltages. And so for transformers, you guys know what transformers are?
Yeah.
It's an ancient alien race sent here to protect the Earth from invaders, and they're mechanical devices.
Interesting.
No, so transformers are just devices. Let's do a brief thing. The power of a device is always equal to the current times the voltage. Does that make sense?
Mm-hmm.
And so sometimes we want to maintain the power because power is what does work. But we may want a low voltage, high current, or we may want a high current, low voltage. And so what a transformer does is it changes the current and the voltage. As you increase the voltage, what would happen in a transformer to the current?
Current goes down.
Yeah, and vice versa. Does that make sense?
Yeah.
Okay. So what they're saying is we have a transformer, and what they do is they look like this. You have a source coming in. So usually they look like this. And so the wire, there's a number of turns this way, and then there's like a number of way more turns another way, depending on whether you're stepping it up or stepping it down. And so what that does is that has an influence on the voltage where the power doesn't change, and this is all based on the relationship between electric fields and magnetic fields. And so it can affect the current, which in turn affects the voltage, but it doesn't necessarily change the power, okay? And so normally if this was our power source here, this would be called the primary, and then this would be called the secondary coil. And we could step up or step down based on the number of loops on which side, okay? And so when they say they step up from 8 volts to 2,000 volts, what does that tell us about the current?
It goes down.
Yeah, so the current will go down. The power would be the same no matter what based on this relationship. All right, cool. So now that we kind of basically understand that, the relationship is proportional. So the power is the same. In other words, the power of the primary is equal to the current of the primary times the voltage of the primary. And then the power of the secondary is equal to the current of the secondary times the voltage of the secondary coil. But these two never change. Does that make sense? So really what we're saying is that IP VP is equal to IS VS. Now what I could do is if I divide both sides by V sub S, right? And divide both sides by IP, I get this relationship of VP VS over IS IP. Okay? Does that make sense?
Why did you do that?
Well, you'll see why in a second. All right? They give us some information. Now, and if we backtrack without a lot of proof, another way you could write this too, and this is how we're going to do it in this problem. Same thing, it's a proportion. So I know that my current of the primary over the current of the secondary is equal to the voltage of the secondary over the voltage of the primary. And if we work backwards and we looked at a couple formulas back, we could calculate the current or the voltage based on the number of turns. And so then, I'm just going to skip past that proof. We know that the number of turns in the secondary is equal to the number of turns in the primary. And so what we have is we have an equivalency between three ratios. In other words, these are all proportional to one another because they're all connected to this one transformer. And so the question they asked us originally is they said our secondary coil had 4,000 turns. What is, find the number of turns of the primary coil based on the fact that they step up from an 8 volt to a 2,000 volt. And so, based on this relationship, we're going to take this information, and they're asking us for the number of turns on the primary, right? So if I solve for that, I get, this comes up here, this goes down here, that goes up there, so I should get NS VP all over VS, right? So the number of turns of the primary coil should be equal to the number of turns in the secondary coil times the quantity of the ratio between the voltage of the primary coil all over the voltage of the secondary coil. And we have all that information. We said that N sub S is 4,000 turns. Okay. We have that the primary coil, if we're stepping up, that means the first number they gave us was the primary coil, was 8 volts. And then the secondary coil was 2,000 volts. And they gave us a current, but that's really more for part B of the question. Does that make sense? So this is all I need for now. So plug it in. So I say that the number of turns on the primary coil is equal to 4,000 times 8 volts all over 2,000 volts. Our units, volts cancels. This is 4,000 turns, so we get turns on the end here. And if you do the math, I think it's just 16 turns, right? Because 2,000 goes into 2,000 one time, 2,000 goes into 4,000 two times. 2 times 8 is 16.
Is that why like some motors are called 12-turn motors and some are called 16-turn motors?
Yeah, there's a relationship. Yeah. I always call them loops because when I went to college, that's what my professor always called them loops, but really they're turns. Okay. I think it was the assistant. It wasn't the professor. So when I say loop, I mean turn. So if you're reading your textbook and trying to follow along on your textbooks, I apologize. Just know that. All right, so I'm going to draw a picture so you kind of have an understanding here. I have a voltage source, right? It comes out. This is my transformer. And my primary, this is my primary here. That was my transformer sound. This has 16 turns. I'm not going to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
Now make it 4,000.
So now that's 16 turns. Right? Now this one has 4,000. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18, 19, 20, 21, 22, 23, something. 3,009, 2,009. 3,999, 4,000 turns.
So,
And then that comes back around to here. Or somehow it closes the circuit. But at 16 turns, I have 8 volts on this end. And then because I have 4,000 turns here, and this is the secondary, this gives me 2,000 volts. So I could change, but the power remains the same because the current, I believe, was like 2 amps or something like that, right? So what's 2 amps times 8 volts?
16.
So what's going to happen to the current way over here in order to maintain the power?
go down.
It's got to go way down. And so the total power should always be 16, right? Was it 2 or 0.2?
It's 2 amps.
2 amps, yeah, so it's 2, Right, so if you guys are confused, what I'm saying is the power should always be the current right? So like the power of the primary should be the current of the primary, and I think, well, I got to read the question. I don't know if that's the current of the primary or secondary. Oh, that's the secondary coil. So my secondary coil has a current of 2 amps. And the voltage, what was the voltage on the secondary? 4,000?
Oh, I thought it was 2,000.
Oh, 2,000. Yeah, I'm getting the 2,000 and the 4,000.
I don't know what it was.
It was 2,000 volts. And so if you do the math on that, it should be 4,000 watts. Right? Is that right, guys? Okay. Now, it doesn't ask that, but I'm writing it down because I want you guys to kind of understand the relationship.
This is Rag's asking to bring up.
Oh, just set it right back there. Okay. Thank you. And so, what do I know? I know that the voltage right here should be 8 volts. So what does that mean about the current? How can I figure out what the current for the primary is?
Equal 4,000.
Yeah, whatever it is, it's got to equal 4,000. So what do I multiply 8 by to get 4,000? Is that 50 or 500?
500.
500. So it should be 500 amps. You see how that works? That's what transformers do.